Okay. Okay, let's get started, guys, without any further ado. Let me share my screen as well. So today will be the first class of our course where we will be talking about networking fundamentals, which is a very important prerequisite for cybersecurity. Let me share my screen on both the meetings. Right. Jaspreet, is the screen visible? Can you see the screen? I hope everyone else can see the screen as well, guys. Yeah, okay, perfect. So in today's class, as mentioned, we'll be talking about networking fundamentals. And when you talk about networking fundamentals, there are three important definitions to know first. Okay. What is networking? What are networks? And what are hosts? So when we talk about networking, in an organization, you have multiple sorts of devices, guys. You have routers, you have switches, you have your client operating system, desktops, again, the employees' devices. You have your servers, again, different types of servers, web servers, FTP servers, DHCP servers, DNS servers, SMTP servers, simple mail transfer protocol servers. Okay. So you have all these sorts of devices in an organization. The organization is a compilation of all these devices connected with each other and communicating with each other and transmitting data. So the concept of networking is basically connecting those devices. Okay, so it is the practice of connecting information devices with each other so that they can share resources and information. Now, this connection can happen in multiple ways. You can either connect them through Ethernet cables, okay, or you can connect them through Wi-Fi, okay, whatever it be. But the process of connecting these devices with each other so that they can share information with each other is called as networking, okay. And that collection of devices, or the collection of those interconnected devices, is called as a network, okay. So in a network, an important point to note is every device can communicate with the other device, okay. Only if a device is in a network, it can communicate with others. If it's an individual device with outside a network, it means it cannot communicate with them. Okay. In a network, every device can communicate with each other. Okay. And in that network, each device is called as a host. So host refers to any device connected to a network that can transmit or receive data. As mentioned already, examples are computers, routers, printers, mobile phones, IP cameras. Okay. Your earphones sometimes, okay, whatnot. Okay, so now, just like how we humans have our names to identify each other, these devices also have their respective identity, and that identity is called as an IP address, Internet Protocol Address. Okay, so now, firstly, when these IP addresses were invented in the 1950s or so, there were multiple iterations of it. There were multiple, I would say, experimentations. Like there was IP version 1, IP version 2, IP version 3. Again, they didn't work out successfully. What practically worked out was IPv4, Internet Protocol version 4. And we're still using IPv4 addresses even in today's world. Okay. To define an IP address, IP addresses are basically the unique identifier for every host on the network. So each host on the network, each device in the network has a unique identifier. That unique identifier is known as an IP address. Okay. And these IP addresses allow for communication to occur between the hosts. Okay. And each of these IP addresses has an important, again, has a few important properties to it. Let's discuss that now. Okay. Before that, any questions or doubts up to this point? I hope the audio is clear. I hope the video is visible. Any questions, any doubts? Akash, VR, Rajendra, Chandrasekhar, Umar, Vashif, Parv,
No, sir.
No, sir.
Jaspreet. Jaspreet, can you hear me? Am I audible? Hello? Oh, I think Jaspreet is here. Okay. But anyways, coming back to this. So let's talk about the properties of an IPv4 address right now. So when you talk about the properties, firstly, it's a 32-bit address. Now what I mean by 32-bit is that it contains 32 zeros and ones in it. A bit is the smallest data value a computer can hold or it can store. It can either be the value of 0 or it can either be the value of 1. Okay. Now your IPv4 consists of 32 zeros and ones as such. And that entire 32-bit address again is divided in 4 parts equally of 8 bits each. And each of that 8-bit portion is called as an octet. Octa represents 8. And each octet is divided by a dot symbol. And this is what it typically looks like. So you can see there are 8 bits here. 1, 1, 0, 0, 0, 0, 0, 0. So 8 zeros and ones. Then a dot, then another 8 bits, then a dot, then another 8 bits, then a dot, and then another 8 bits. Okay. So these are the again binary bits that you see. So the language of zeros and ones is commonly known as the binary language because there are only two numbers or two characters. Binary is two, okay, zeros and ones. Okay, but we humans don't easily understand these binary numbers. Okay, what we regularly use and what we regularly understand are decimal numbers. Okay, numbers from 0 to 9. So now I'm going to show you how do you convert any binary number to a human readable decimal number. So this number or this octet here, 11000000 is actually equal to 192. This octet 10101000 is actually equal to 168. This number 00000000 is simply equal to 0. And this number 00001010 is actually equal to 10. Okay. So now I'm going to show you how do you convert any binary number to a human readable decimal number. Okay, because now that is going to help you in understanding the range of IP addresses as well. Okay. So firstly, if we take this octet here, let's say 10101010. Okay. So I have 8 bits here. Now I'm going to show you how do you convert these 8 bits or an octet into a human readable decimal number. Okay, so rule number one, or step number one, I would say, is assign the values of 2 power to each bit from right to left. So you start from 2 power 0 and go all the way up to 2 power 7 from right to left. Now, if you specifically ask me why only 2 power everything, because it's a binary number, there are only two possibilities. One second, I think there's some background disturbance. Is someone's mic unmuted? I think your mic is unmuted. There's some background disturbance from your mic. Could you please mute that? I can mute myself, no worries. Okay, anyways. So again, as mentioned, firstly, you assign all the values from 2 power 0 all the way up to 2 power 7. So rightmost bit has 2 power 0 under it, then 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, 2 power 5, 2 power 6, and 2 power 7. Okay. Once these values are assigned here as such for each bit from right to left, then you multiply the lower value with the top bit and you add it to the next one. So that's rule number 2. Multiply each lower value to the upper bit and add it till the end. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So irrespective of what the upper bit be, you just have to multiply the lower value with the top bit and you add it to the next one. As simple as that. So no matter what octet it be, no matter what binary number it be, you write down these values at the bottom, you multiply the lower value with the top bit and you add it till the end. Okay, so now to perform this calculation, let me write down these values first from 2 power 0 to 2 power 7. Anything to the power 0 is always equal to 1. It's a mathematical rule. So 2 power 0 is equal to 1. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, 2 times, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times, that's 16. Similarly, 2 power 5 is 32, 2 power 6 is 64, and 2 power 7 is 128. Okay. Now that you have all these values here, okay, you can substitute them. 2 power 0 into 0. So 2 power 0 is 1. So 1 into 0, that's simply 0 plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, again 0. 2 power 3 into 1, that's 8. 2 power 4 into 0, again 0. 2 power 5 into 1, 32. 2 power 6 into 0, 0. 2 power 7 into 1, 128. Now that you have all these values, if you add this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans see the number 170 as 170, the computer understands it as 10101010. Okay. It's something like high frequency, low frequency, high frequency, low frequency, high, low, high, low. When that exact sequence of the frequencies flows through a computer, it understands it as the number 170. So that is how you convert human readable numbers, sorry, computer readable numbers into human readable numbers. Okay, is that clear? Any questions in this procedure? Now, the reason I'm explaining you all this is so that you can understand the range of IP addresses. Okay, so I'm going to come to that in a minute. But before that, any questions or doubts? Akash, Rajendra, Chandrasekhar, Umar, Parv, Rama Rao.
No, sir.
We are.
No, sir.
So if this is
No,
clear,
sir.
I have two other numbers here. And if you have a pen and a paper beside you, I want you to give me the answers for this. Example 1 and example 2. No cheating. Don't ask ChatGPT and stuff. Try this out on your own. And if you have the answers, you can let me know what the answer is. So example 1, 0, 1, 0, 1, 0, 1, 0, 1. And example 2, all ones. Take your time. No rush. Okay. Try to give me the decimal values of these.
So count all numbers. 128, 4, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1.
For which one? For example 1.
All these.
No, again, as mentioned, you have to replace those values at the bottom, multiply with the upper bit, right? Sorry, who's asking the question? Just like in the last example, Rajendra, right? So just like how we did it in the last example, wherever there's 1 on the top, you're multiplying that value. Wherever it's 0, it's simply 0 itself, okay? So 2 power 0 into 0, that's 0. 2 power 1 into 1, 2 power 1 is 2, so 2 into 1, that's 2. So wherever you have 1 on the top bit, you're keeping that value. Wherever you have 0, you're just writing it as 0. So in a similar fashion, give me the answer for the next examples. Example 1 and example 2. 0, 1, 0, 1, 0, 1, 0, 1. And
Example
all.
185, sir.
Example 185, correct answer. So let's just verify that. So again, 2 power 0 into 1, that's 1. Plus 2 power 1 into 0, that's 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, that's 0. 2 power 4 into 1, that's 16. 2 power 5 into 0, that's 0. 2 power 6 into 1, that's 64. And 2 power 7 into 0, that's 0. So if you add all this up, 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Correct answer, guys. Example 2. Any answers on example 2?
263, sir.
263. Okay. Any other answers? That is slightly wrong. Off track a bit. 255. Good answer. Okay, that's the correct one. Okay. So again, you just add everything up. So there's a 1 everywhere. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So if you add all that up, you get the number 255, guys. Minor addition miscalculation somewhere probably, guys. So again, but no worries. So again, correct answers. Now the reason I'm explaining you all this, guys, as mentioned, again, as now you'll not be converting these things in real time anywhere, but this makes you, or this gives you a proper understanding of what the range of IP addresses are and why specifically that range exists. Okay. So if I go to the first IP now, if I had to get the first IP, what do? I just put zeros everywhere because that's the minimum value possible. When I put zeros everywhere, the first IP will be simply 0 dot 0 dot 0 dot 0. And if I have to get the last IP, can anyone tell me what I should do? How do I get the last IP? How do I get the maximum value possible? I put all ones everywhere. Exactly. So when I put all ones, that is the last IP, which is 255.255.255.255. So your IPv4 addresses will only range from the number 0000 to 255, 255, 255, 255. Okay, so your IP addresses cannot exceed or cannot go beyond 255. Okay, every IP address that you have will always exist between this first IP and the last IP. Why is it stopping at 255? The logical reasoning: all octets have 8 bits in them, and when you put all ones in each octet, okay, the maximum value it can reach up to is 255. It cannot go beyond that. Okay, in an octet with 8 bits, if you put all ones, we calculated just now, you got the number 255. Okay, you cannot go beyond that. You cannot exceed beyond that. So the last IP is 255.255.255.255. And if I have to calculate how many IPs are there in total, each bit here has two possibilities, right? 0 or 1. Okay, so if you notice, there are 32 bits in total, and each bit here is having two possibilities, 0 or 1. Okay, so two possibilities into 2 into 2 into 2 into 2 into 2, 32 times, which is 2 raised to the power of 32. Okay, and when you calculate that, you'll get a value close to approximately 4.3 billion IP addresses. So back then, when these IP addresses were invented in the late 1950s or so, they thought 4.3 billion IP addresses was a very large number because back then you didn't have mobile phones. You didn't have, again, not many people had access to internet as well. Okay. So they thought 4.3 billion IPs is a very large number. It'll be sufficient for the rest of eternity and whatnot. But again, they were a bit ahead of themselves. So fast forward to 2025, the population itself is 9 billion people, close to, I think it's 8 or 9, I'm not sure exactly. But again, it definitely exceeds the number of IP addresses available. Right? So that's why what they did was they started segregating these IPs. They started dividing these IPs into multiple classes and multiple categories like public and private and special IPs. Okay. So we'll cover all those categorizations later on, don't worry. Okay. So, but again, these entire 4.3 billion IP addresses are not in one single category. There are multiple categories in them. Okay. There's something like classes. Okay, 5 classes: class A, B, C, D, and E. And again, in each class, there's something called public and private IPs, etc., etc. We'll cover all that later. Before that, let's talk about the sequence of IP addresses. So now we know the first IP, we know the last IP. What about the IP addresses in between? How are the IP addresses progressing one after the other? Okay. So for this also, there are two simple rules, very simple rules. Okay. Okay. If you remember these two rules, it's very easy to understand the entire sequence of IPs. So rule number 1 is you always start incrementing from the rightmost octet. Okay. So for example, if here is my first IP, let's say 0000. Where is this? Yeah, here it is. Okay, so this is my first IP 0000. Okay, now if I have to get the next IP, sorry. Okay, what I have to do is I have to just increment the rightmost octet. Okay? Increase the value for the rightmost octet. So always start incrementing from the rightmost octet. That's rule number 1. So if I have 0000 as the first IP, next IP would simply be 0001. Next IP 0002. Next IP 0003. Next IP 0004. Next IP 0005, 006, 7, 8, 9, 10, 11, 12, 13, 14. Goes all the way up to 000255. Now please note, after 000255, you cannot have a value like 000256. This is not possible. Okay, it's an invalid IP. Whatever IP addresses you have, they will always exist only until every octet having 255, not beyond that. Now, once you reach the maximum value in that octet, here comes rule number 2. Reset that octet back to 0 and then increment the next octet beside it. Okay, so this 255, cycle back to the first value, which is 0, and the next octet, the one left to it, will increment by 1. So then you have 1, 0. Okay. Now after 1, 0, don't directly jump to 0, 0, 0, 2, 0. That would be wrong again. Remember rule number 1, always increment from the rightmost octet. So after 1, 0, you have 1, 1, then 1, 2, then 1, 3, then 1, 4, then 1, 5, then 1, 6, which goes all the way up to 1, 2, 5, 5. Okay. Once it reaches 255, it cycles back to the first value 0 and then the next octet increments by 1, then you have 2 0. Okay, so if you see there's a pattern here, 0 0 to 0 2 5 5, 1 0 to 1 2 5 5, 2 0 to 2 2 5 5, 3 0 to 3 2 5 5, 4 0 to 4 2 5 5. Like that, the pattern keeps on repeating again and again and again. 5 0 to 5 2 5 5, 6 0 to 6 2 5 5, 7 0 to 7 2 5 5, 8 0 to 8 2 5 5. It goes on and on and on. And somewhere down the line, you would have 2 5 5 0 to 2 5 5 2 5 5. Both the octets are full. They've reached the last value 255. What do you do after that? Wherever there's 255, you cycle them back to zeros. And then the next octet increments by 1. Okay. So if you notice now, you have 0 0 again. So the same pattern repeats again. 0 0 to 0 2 5 5, 1 0 to 1 2 5 5, 2 0 to 2 2 5 5, 3 0 to 3 2 5 5, and finally 2 5 5 0 to 2 5 5 2 5 5. So once these octets are reached to the maximum values, this 1 now changes to 2. Okay. So this is the pattern of the next octet. Okay. 0 0 0, oh sorry, 0 0 0 to 0 2 5 5 2 5 5. That's the first pattern. Okay. Then 1 0 0 to 1 2 5 5 2 5 5. That's the next pattern. 2 0 0 to 2 2 5 5 2 5 5. Next pattern. 3 0 0 to 3 2 5 5 2 5 5. Next pattern. 4 0 0 to 4 2 5 5 2 5 5. 5 0 0 to 5 2 5 5 2 5 5. 6 0 0 to 6 2 5 5 2 5 5. 7 0 0 to 7 2 5 5 2 5 5. And finally, somewhere down the line, you would have 2 5 5 0 0 to 2 5 5 2 5 5 2 5 5. Once all these three octets are full, they cycle back to zeros, and the last octet 0 changes to 1. Okay, so whatever repeated from the first IP 0 0 0 0 to 0 2 5 5 2 5 5 2 5 5, same entire pattern will now repeat again from 1 0 0 0 to 1 2 5 5 2 5 5 2 5 5, 2 0 0 0 to 2 2 5 5 2 5 5 2 5 5, 3 0 0 0 to 3 2 5 5 2 5 5 2 5 5, 4 0 0 0 to 4 2 5 5 2 5 5 2 5 5. Like that, it goes on and on and on. And somewhere down the line, you would have 2 5 5 0 0 0 to 2 5 5 2 5 5 2 5 5 2 5 5, the last IP. And that is how, if you count each and every single IP, you would have a total of 4.3 billion IP addresses. Okay. I know, slightly overwhelming today, slightly confusing because this is your first-hand experience with IP addresses. But I would recommend going through this recording again and this documentation again as well. The entire sequence is written down over here. Okay. So as you can see, 0 0 0 0 to 0 to 2 5 5 2 5 5 2 5 5. Then 1 0 to 1 2 5 5 2 5 5 2 5 5. 2 0 to 2 2 5 5 2 5 5 2 5 5. This pattern keeps on repeating, and somewhere down the line, you would have 2 5 5 0 to 2 5 5 2 5 5. So this entire pattern again repeats. So from 0 0 0 to 0 2 5 5 2 5 5, same thing repeats from 1 0 0 to 1 2 5 5 2 5 5. Where is it? Here. Then 2 0 0 to 2 2 5 5 2 5 5. 3 0 0 to 3 2 5 5 2 5 5. And finally 2 5 5 0 0 to 2 5 5 2 5 5 2 5 5. Whatever pattern repeated from here, 0 0 0 0 to 0 2 5 5 2 5 5 2 5 5. Same pattern repeats from 1 0 0 0 to 1 2 5 5 2 5 5 2 5 5. 2 0 0 0 to 2 2 5 5 2 5 5 2 5 5. 3 0 0 0 to 3 2 5 5 2 5 5 2 5 5. And down the line, 2 5 5 0 0 0 to 2 5 5 2 5 5 2 5 5 2 5 5. That's the entire set of IP addresses available. Okay, and these entire 4.3 billion IP addresses again are divided in 5 categories called classes: class A, class B, class C, class D, and class E. And again, in each of these classes, there's a subcategorization. Class A has public and private IPs. Class B has public and private IPs. Class C has public and private IPs. Class D and Class E are exceptions. There are no private IPs in them. All of them are public IPs itself. Okay, so that is the entire categorization of IPs. Now, don't worry what classes are. I'm going to cover this in detail in the upcoming sessions. I'll explain what public IPs are, what private IPs are. Okay, what are classes? What's the range of each class? Okay, what is the relevance of each class? Each class is a unique set of network and host portions. So what is class C significance? What is class B significance? What is class A significance? Class D and class E are special IPs. I'll explain that also. What is subnet mask? Okay. How do you assign a private IP automatically or manually? What is a DHCP server? What is the DHCP protocol? What is DNS protocol? We'll cover all this in the next session, guys. Okay. So that's it for today's class. A brief introduction, a very simple introduction on what IP addresses are. Since these are demo sessions, guys, the sessions are a bit short. Okay. And they're starting a bit late because all the students need to join. So I'm waiting for that while again for the first few minutes. Okay. And yeah, tomorrow we'll be talking a lot more in depth on IP addresses, what again these important protocols are, what the categories are. We'll cover all that in the session tomorrow, guys, without fail. Okay. So yeah, any questions or doubts up to this point?
Yes, sir. I have questions.
Yes, go ahead.
In subnet, one subnet, suppose you give the /24 CD.
Mhm.
So how many IPs are there? Is it 255 or
255
256?
/24 is 255 /16 is 255 into 255 /8 is 255 into 255 into 255. So don't worry, I'll cover that. We have not covered that
But
yet.
when you check in Google says 256 sometimes.
Because you're including 0 IP as well.
Yes, sir.
But you cannot use that IP. So since I'm ignoring 0 IP, the 0th IP, you have 255. And one more thing, you have to ignore the 255th IP also. So /24 is just 254 IPs to be precise. Okay. But as a round figure, I'm saying 255. Okay. 256 because you're including 0 also. Okay. So if you notice over here from this IP, where is this? 0000. Okay, to 0000255. How many IPs are there in total? Atish, are you there?
256.
256. So that is why you get the value 256 there. Okay. So don't
And
worry what /24 is. I haven't covered that others. So you might see.
one more thing, sir. I heard about the IP addresses. There is two IP addresses not using. They used the as a network. First, two IPs.
Sorry, come again. What?
There is into 55 IPs there, but they used 253 IPs.
No,
And
254. So again, you don't use the first IP, which is this called the network ID. Oh, sorry. This is the network ID here. Okay, and this last IP, 0000255, where is this? Yeah, this is called the broadcast ID. Okay, so remaining IPs left out, if you notice over here. So if you're ignoring 0th IP and if you're ignoring the 255th IP, okay, so in between the remaining IPs are 254 IPs. So here this will be 0.0.0.254. So these are the only usable IPs you have. Okay, and then this first IP is usually given to the default gateway. Default gateway is nothing but your router. Okay, so excluding the router, then you have other 253 IPs. Okay, but the usable IPs will always be 254. Okay, the 0th IP is called the network ID, which you shouldn't assign to any system. 255th IP is called the broadcast ID. You should not assign this also to any system. Okay, you cannot assign actually. Okay, so the only usable IPs you'll have are from 1 to 254. Okay, so don't worry others. This might seem a bit confusing to you, but I'm going to explain all this in the upcoming sessions. Okay, so that's the list of usable IPs, Atish.
yes, sir.
Right. Any other questions? Any other questions, guys? This is a bit off topic, guys. This is a bit more in-depth in IP addresses. I'm going to cover this in the upcoming session. So for the others who don't understand all this, don't worry. Okay, it's nothing out. It's a bit slightly out of context. Okay, we'll cover all this in the upcoming sessions in detail. Okay. Other than that, any other questions, guys, from this class or even from the networking topic? Anything? Yeah, Rajendra, your mic is unmuted.
So, what are the topics covered under this duration, sir?
In this entire course duration, just a second. These are the entire list of topics we'll be covering, actually. I think the institute must have shared this document to you.
Yes,
Not sure if it did or
well,
not,
okay.
but this is the entire list. So, and one more thing, I have taken up a demo session yesterday, Rajendra.
Yes.
Again, a brief intro. So I'm not sure if you were there or not. So in that also, I've given a brief explanation on all the topics we'll be covering. in these 5 phases of the hacking cycle. Okay, so this is the entire list of topics. This will be shared to you by the institute directly. Okay, so all again, what we are learning right now are networking basics. Okay? So after this, we'll be covering virtualization. After that, we'll be covering Linux and Windows commands. Okay, and then the remaining concepts: information gathering, scanning, gaining access, maintaining access, reporting or clearing cases, and a few bonus concepts as well. Okay, so yeah, that's the entire list of contents.
Okay.
Any other questions, guys? Just breathe. Any questions? Can you hear me? Am I audible? Maybe this. Okay. Any questions on your end just for today's class? All clear. Yeah. Right. So again, this the link that you are on, Jaspreet, is the confirm link actually. All the other students have not registered yet, so they are on the demo link. Okay. So they'll be joining your sessions soon once they register. Okay, that's why you might not be able to hear others' voices. Okay, since you're already the registered one. Okay, so you're on the other link. Okay, so yeah, that's that. Nothing further for the session today, guys. We'll be connecting back tomorrow, and we'll be talking about a lot more in depth on networking fundamentals. Okay, so we'll cover that, a few other topics in the next session. Okay, so that's it for today's class. Nothing further. We can exit the session here. Bye bye. Have a good day. I'll see you tomorrow. Thank you.
Yeah. Thank you, sir.
Thank you, guys. Bye bye.